Recording in progress.
Test, test. Can people on Zoom hear me?
Nope. Well, maybe. No, they cannot.
All right, how about now? Can people on Zoom hear me?
Yeah.
All right. Good afternoon. How's everyone doing? Woo. All right. So Josh has an announcement about office hours. Do you want to?
Oh, sure. My office hours are at the times listed. I only had one person today. It was fun. All right, go.
Yeah. Show up to office hours. What's coming up? Let's see. Today is the 12th. So we have Lab 4, which is due soon. Project 1B is going to be due next Wednesday. We are actually getting a bit close to the midterm. So midterm's going to be in 1 week. How many people are ready? How do people feel? Good? Bad? Kind of, mostly bad, kind of in between? Well, this Wednesday, or next Wednesday, we'll actually have just a midterm prep lecture, just kind of an Ask Me Anything, so you can ask any questions you want. And just to set up for that, we'd like to ask, what do y'all want covered? So we'll be asking this again on Friday if you have more things you're not thinking about right now. But just right now, what do people feel they're struggling with the most that we should focus on Wednesday? Yeah? 61A style, like 61A style, like coding questions. Okay, coding questions. Why am I holding this? Hang on. All right, 61A style coding questions. Java syntax. Anything else people want covered? Yeah. Inheritance. Overloading, overriding. Anything else? Let's see, back there. Different forms of lists. I see Zoom chat is all right. Yeah. Huh? Comparators and comparables. Okay. Yeah. Yeah. Huh? Generics. Ooh, oh no, we're echoing. Anyone from the back? I'm mostly hearing from the front of this room. Is there anything that people in the back want like covered? We are echoing.
I'm working on it.
Do you unmute yourself here?
Oh, I guess I must have.
All right, there. Does anything we want covered for a review session in the back? Anyone? Yeah. Yeah. Generic question, or will we be expected to know nested array lists? I'm not sure what you would...
List of a list of something?
Yeah, that's fair game. Like, a list of a list is just the same as a list of integers, or... Yeah, 2D arrays, that's fair game. You can have an array of arrays. Yeah. Yeah. Yeah, we can take the concepts that we discussed and then use them on the same concepts that we used. Yeah. We will be providing a reference card containing all of the interfaces that you'll be needing on the exam. So you don't need to memorize anything specific about like the syntax or like the syntax of like the objects, right? So if there's something that we want you to use, then you will know how to use it. Yeah. Are we allowed to make cheat sheets? I believe we're offering one cheat sheet.
That's what I usually do.
Yeah.
And then we'll give the reference sheet in advance, presumably?
Yes, the reference sheet is about to be released, I think, in a few days-ish. Yeah. Yeah, on some of the older midterms, we discussed int lists. The int list is effectively just the first version of the singly linked list that we were discussing. We called them like naked singly linked lists, I think, this time, right? Yeah. It's just specifically using integers. Yes, you will be given any interface that you're expected to use. We don't expect you to memorize specific interfaces because those are basically dependent on who designed the interface itself. Is there a reason why you have to handwrite your cheat sheets? Yes. The main thing is that we actually want you to write it yourself, right? If you have a typed cheat sheet, it's just easy for someone to write one and then just share it with everyone else. The handwriting process is actually where you get the most benefit out of the cheat sheet because you're trying to consolidate all the information in the class down into a single sheet of paper. Is there a reason why we're not allowed to write it on tablets? Yeah, we've had issues in the past where people tried to pass off their work as if it was handwritten, but it was actually just typed up in a handwritten looking script. Yeah, it's happened in the past. Yeah. Can DSP students type it out? Yes, contact us for details. If you have an accommodation that's specific to that, then we can probably make an exception. Yeah, or if you're in the process of getting that accommodation, then let us know as well. Yeah, no worries. The cheat sheet preparation is more for you to learn it. Ideally, if you write your cheat sheet, then you will not actually need the cheat sheet.
So will we be given like the attributes and methods for like int list class, single linked class?
Yes, for classes that we covered, you generally are going to be given the interfaces that you'll be working with. Basically, every way that you are allowed to interact with this thing will be provided. All right. I think that's most of the questions. Let's get started with today's lecture.
All right, thank you, Justin. There's a few more in chat if you want to stick them on this slide so that they're official. Okay, folks, today's our last day of working on Java syntax. After this, we're going to start doing data structures. So let's wrap it up and learn the things that we need to know. So we're going to try and build an array set today. That's going to be our goal. And we're going to use this to showcase some new syntax. So the first thing I'll tell you is what an array set is. In Python, you've seen sets before. You can create a set. You can add items to them. And you'll notice this line, we add Oakland, but it has no effect. Why? It's already there. So a set can only have one copy of each thing. We're going to build that in Java today. We're going to add a few extra things we haven't seen in our data structures before, like the ability to iterate over it, check if two array sets are the same, and also convert it to a string. Okay? That's what we're going to try and build today, this thing on the left. So we are going to start with an implementation already there. I'm going to show it to you in IntelliJ. It's going to have three methods already, one that adds values, one that checks to see if they're in there called contains, and size. I'm not going to have a resize method just to keep things simple, so this will break if you add more than 100 items to the set. Because this basic functionality is very similar to things we've done before, I'm going to skip coding it live, and we'll just jump in over here. Now first I need to actually pull the lecture code repo to have the most recent stuff, and then we'll open it up. Okay. All right. So after doing this, it appears. Here's our array set. All right, good. And this is the whole class. So let me just show you a rough picture of what's going on. It's an array set of things. When you create one at size 100, the contains method just iterates over the entire array and says, is it there? Notice that I used .equals instead of equals. You might remember from an earlier lecture that's for a good reason. I'll say it again in the slides in a second. So there's not much here. Look through the array and see if it's there. And then add, what we do is we first check to see if it contains the item. If it doesn't, then we put it in. I also have here, we don't allow the set to have nulls. You could do that either way. It's just our decision. I decided a set shouldn't be able to hold null. Okay? Any questions about this very first idea? Okay. That's our array set. Just a couple of small things. There's this funky thing when we create the array set where we have to say new object and then do this cast. We haven't talked about casting this semester. We won't really. But this is just a thing you have to do to create generic arrays. You'll do this in 1B. Okay. And IntelliJ will yell at you. If you look, it'll have a little warning, but that's just what we have to deal with. The other thing is in the contains method, the other quirk is that instead of using equal equals, we use dot equals. And that's because equal equals does what? It compares the bits, checks the addresses. And we'll talk about equals in a little more detail later today. Okay? All right. Any questions about array set? All right. So let's talk about iteration. Let's talk about what you can do in Java that's very nice with built-in sets or lists that we can't do. Okay? In a real Java set, if I add the numbers 5, 23, and 42, and then I iterate over the set using this notation here, which you've seen before, it's beautiful. It's like very simple. I reincarnates itself as each value, 5, then 23, then 42. That will not work with our code. This type of loop in Java is sometimes called an enhanced for loop or a for each loop. And we're going to try and build the functionality into our class so that this does work. Now, you may remember that Java doesn't support operator overloading. So there's no way that we could ever add using a plus sign to our array set. But it does support this special type of for each. And it's going to take a little while to build this. But this is not a form of operator overloading exactly. I mean, I guess you could argue, I guess we're overloading this colon. But I don't think about it that way. If we try and do that with our array set, Java will yell at us, and it'll say, you can't iterate over this. You can only iterate over arrays or Java laying iterables. Okay, but instead, you gave me an array set. So what we need to do is tell Java that an array set is an iterable. That's what we're going to try and do. Okay? And that's going to be our goal. But this is a step along the way. Okay. Yes?
Why don't we just use the array set to extend the link to the array list because they have like versions of it?
The question was, why don't I make an array set extend our array list class from before? I would say that's actually an abuse of extending notation because a set isn't a list. So it would be inappropriate to say that an array set is an array list because they're two different things. I'll come back to this point when we talk about some software engineering lectures. There are classes in Java that are written like that that make things painful. I'll come back to that much later. Okay. But I'm glad you fell in that trap. Much more senior programmers have as well. Okay. So why can't I do this? Why can't I say for int I in my set? It's because this is not an iterable. Okay? So the way that the enhanced for loop works is it needs an iterator. It needs an iterable. And the way that, how this all works under the hood is that the iterable object has a method called iterator that returns a thing called an iterator that in turn has its own two methods. That's more than you can possibly digest with just this example. And so what we're going to do over the next 10 minutes or so is understand what's on this slide. Okay, so this is the concise statement, but it doesn't make sense to most of you. Okay? So the first thing I need to let you know is that in Java, whenever I iterate over a Java set, let's say, or anything with the colon, really this code on the left, this nice, beautiful idea, hey, X, please be each element of the set, it's really doing what's shown on the right, a much messier process. It just hides this from you. So what it does is it actually goes to the Java set, and it says, please give me an iterator object. Okay? I'm going to call the iterator object a seer. That's the name of my variable. It sees what's in the Java set. And then we're going to keep asking the seer, is there still something in the set? If so, give me the next item, and then print it out. So these two pieces of code are literally the exact same thing. This code on the left is just a shorthand for what's on the right. Okay? So just be aware, that's really how it's going to work. Okay? So let's think about what's really happening for a while, and we'll make our code actually work with the, I'll call ugly iteration, and then later we'll come back to nice iteration. Before I take any questions about this, I want to show you a nice animation showing how this seer works. So if my Java set has an underlying array of 5, 23, 42, other elements not shown, the way it works is I create a seer, and where do you think the seer is initially looking? At the 5, indeed, there it is. So when I start running this code, the seer is looking at the 5. And then we ask the seer, is there still something to see? Yeah, true, okay? So then what we'll do is we say seer.next. Now the .next method is a little complicated. It does two different things. One thing it does is returns what number? 5. And what do you think the other thing is that it does? It advances the seer. So at the same time, the seer takes a step forward, says 5. Okay? Those things happen at the same time. What do we do next? We go back to has next. Is there still something to see? Yes. Okay, and then we call next, and we're going to get what number? 23, and then we're also going to take a step forward. Okay, so we do both of those things. Okay, so we get 23. Then we ask, do you still have a value? Yes. Then we do 42 and step off the array, and now what'll happen if we say has next? We get false, and then we're done. So that's the process. Has next just checks if there's a next value. The next method gets the next value, and it has the side effect of advancing the pointer forwards. Okay? That's what's supposed to happen. All right, any questions? Yeah. In a for each loop, can you modify the object as you're going? Yes. There's a remove method that iterators support, but we're not going to see that in our class. In a traditional for each loop, if I am just, like suppose I do like x equals something, it won't change anything about the data structure because that x is just a 32-bit integer. Yeah. Other questions? Okay. So that hopefully makes sense conceptually. Let's try and do this in code. So we want to make this happen. That's our goal. Now, before I do this, I want to think about, I don't actually have a yell key question for you, this one. I just want you to think about it. So the code on the left is just shorthand for the code on the right. So this is back to those kind of annoying compilation questions that hopefully you got a chance to play around with a little bit on the discussion worksheet and in class last time. But if the code on the left is really the code on the right, which of these 4 checks does the compiler do in order to decide if this code should compile? What does it need to check? I'll let you think about that for a minute or so. And I'll give you a hint, which is there's actually 2 right answers. Okay. So 2 of these things are true. Kind of pace back and forth awkwardly for a minute or so. Because this is also your chance to just look at the code and digest it, ask questions of your neighbor if you're confused. All right, folks. All right, I'm taking the room back. What do you think? So, do you guys think that it checks if the set has an iterator method? Yeah, right. That's right here. The set, Java set, it tries to get an iterator. So A is one of them. What's the other one? D, it checks to see if an iterator, a seer, has a has next and next method. Those are the two things that get checked. All right, any questions that may have come up during the process of thinking about this problem, about anything so far? Okay. All right. So what I want to do is support ugly iteration. This is ugly iteration on the right. You don't usually want to write code like this because it's annoying to make an iterator and repeatedly ask questions, do you have something? You'd rather do this nicer version, but we're going to do the ugly version first. Okay. So to support ugly iteration, what we need to do is add an iterator method. In fact, I'm going to go over to ArraySet, and we're going to actually write this out real quick. So we're going to make a, okay, so I'm going to do iterator integer equals aset.iterator, almost. Okay, we need to do, I'll call it seer, sure, a seer, to match, I think my slides do that. Okay, I need to import the iterator interface. Closer, and now what we're going to do is we're going to keep asking the seer, do you have something else, y is wizard? If so, then I'm going to get the next item. I'm going to do it on 2 lines. On the slides, I think I often do it on 1 line, but just to make it very clear. So this gets the next item and assigns it to I, and then we print to I. So this will not work yet because there is no iterator method. Okay? So we need an iterator method. All right, great. So public something iterator return something. Okay. What's the return type of this method supposed to be? Iterator, right? Okay, capital I iterator. And in particular, it's going to be an iterator over t's because I'm an array set of t's. It says so right there. Now we need to return something. But what the heck are we going to return? How? We don't have anything that implements iterator. What do you think we should do? What do we need? What's missing? Go ahead. Say again. The address where the object is, like you might want to like return me, but I don't have a has next method and a next method. I need something with a has next method and a next method. Where are we going to get that? We're going to make one. Okay, good. So I'm going to do private class, and I'm going to call it an ArraySet iterator, and it's going to implement iterator. Okay, this is the part where if we did this the first day of class, you'd be crying. Now you're probably just slightly confused. Okay, so I'm making a thing which is implementing iterator. It needs 2 methods. What methods? A next and a has next, okay? In fact, if I use this keyboard shortcut, I can get it to do it for me. It's not everything, but it gives me the has next and next. Okay, we're getting closer. It still feels hazy. Like how am I, what? How can I return anything? How do I know if I have next? Like, the wizard, what's missing right now, if we go back to our animation of our wizard, like it's in a certain position. How do I capture that notion that the wizard is in a certain position? Like how can I, where's the position? An attribute of what? Attribute of which class? The iterator class itself. Okay, so I should make a note here that the ArraySet, an ArraySet iterator is the seer. It is the wizard. Yes. Thank you. So there we go. So it needs a property. Private int, I'm going to call it wizard position, wizpos. The position of the wizard. Okay, okay. And how do I usually set one of these variables? With a constructor. So I'm going to make a constructor. Public ArraySet iterator. Well, it's private. I'm just going to get rid of this keyword. You don't need it. It's in a. You can have public if you want, but it's a private class, so I'm not going to do it. So an ArraySet iterator. And what's the wizard position initially going to be? 0 seems good. Do you really need to do this? Not so much, but I think it's nice to remind us what's going on. And then how about has next? Okay, we're getting close. We need to check the wizard's position, so we're going to say if the wizard position is what? Less than what? Size, okay? Size, that's the size of the array. So in the iterator, it knows the set's size that goes with this ArraySet iterator. And if that's true, we can say return true. Otherwise, we return false. There's a shorter way to do this, but I'm not going to do it right now. You could just return wizpos less than size. But As novice programmers, I'm just going to put it this way. How does it know the size? Well, because in array set iterator, it's always associated with the specific array set. If I were to make this class static, this won't work anymore because there's no particular array set in mind. But because I don't have the word static there, it means each iterator is like a baby that's associated with, or a wizard, I guess I should say, associated with that specific array set. We're going deep with object-oriented programming right now. Synthesizing things, yes.
Why can't you just call the iterator, interface and say like iterator dot something to get your iterator?
We can't do iterator dot whatever because there's no like iterator dot to get something from the iterator interface because it knows nothing about sets, array sets. Yeah, we have to build this custom. We're the only ones who know about array sets, so we have to build the thing that walks through the array set. Okay, and then what's next supposed to do? It advances, so it advances, and it also returns the item. So how do I get the particular item I want? I should say T. T item to return equals what? Items whizpause, whatever I'm looking at, right? And then how do I advance the wizard position? Whizpause plus equals 1, and then item will return the item to return. And there we go. We built ourselves this iterator. Could you build weirder iterators that like iterate at the front, then the back, then the middle, like kind of goes like outside in? Sure. Could you go backwards? Sure. Are those the kind of questions that are fun to write for exams? Yeah, you're right. You could do whatever you wanted. Because of course I could start the wizard at the end, you know, and then instead I could do minus equals 1, and then has next is like whizpause greater than 0, something like that. It might not be right, but yeah. So the iterator can do anything we want, but this is the most straightforward possible iterator. Okay? Let's see if it worked real quick. I have at least one complaint. Oh, I need to return what? A new array set iterator, right? All right, now if I try running this code, I think it should work. I don't think I messed anything up. All right, we see 52342. And if you want, you can use the visualizer with the lecture code repository. So if you just go to that repository, you type git clone, the name of the repository as linked on the website. This is the last one where we're going to really use this for a while. So let me just show that to you real quick in case you like doing this sort of thing. You click on code, and then you click this little button. You can clone this repository just like any other, and then if you open the main folder in IntelliJ and you import libraries, you can run all this stuff in the visualizer if you want to practice for the midterm or do experiments. All right, any questions about this? Yeah. If you're at position 1 and the size is 2, so has next means the semantics of wizard position are that when you are in this position right here, next is true. So has next means you've just said 23 and you're standing there. Does that make sense? So it's correct to say true there. Yeah. That's the way I think about it. Has next is, are you currently standing somewhere where you can say something useful? So once you step there, it'll be false. Yeah. Okay, any other questions? So you'll do this obviously in Project 1B. That's where it really cements, but hopefully the story helps, yeah. Could we do a for each loop on the array? That's an interesting question. Ooh, I never thought about that. I'll think about it as we do one more step, but not sure. I don't think so, but there might be a way. I'm not sure what'll happen. Yeah, I'm not even sure if I could figure out how to do it syntactically. Okay, so the one more thing we need to do, actually, I think I should show my slides first. Right. Okay. So the next thing we have, hopefully this all made enough sense that you could start building an iterator yourself. But again, it only really makes sense once you do it yourself. It's just too much to digest while listening to someone else talk and watching someone else write code. Okay, so here, our code, it will not actually work yet if we try to do the pretty iteration here. Okay, so even though this code here works fine and it printed 52342, here we get yelled at and it says array sets do not, like it's not an iterator, it's not an iterable. Okay? So even though an array set has an iterator method Java doesn't know, but there's an interface to do that, which is to, at the very top, simply say implements iterable. Okay, so saying you implement iterable, you're telling the world that you have what? Nope. You have an iterator, and the iterator is what has next. So this right here, saying implements iterable t, means that you have a method that returns an iterator of t, and this method is called, .iterator. And in turn, that iterator has a hasNext and next method. Okay, again, slightly confusing when you first see this, or maybe moderately confusing. But again, once you build it, it'll make more sense. Go ahead, and I'll take you.
I think before we had array set implementing, I think it was the set class.
I never had implementing the set class in this particular example, but you can implement both if you want to implement an interface. So implementing multiple interfaces is totally fine in Java. You just have to implement both of all of their methods. Question?
So is implementing iterables and just checking that you just have an iterator method?
Right, and if I delete this iterator method, for example, so if I go down here and I delete this method, now it's going to yell at me and say, you claim to be an iterable, but you don't have an iterator method.
So it's checking that it has a method that implements
Iterator, yep.
Okay.
Yeah.
So we have to use iterables and iterators together, not like comparable.
Yeah, that's an interesting point. Iterators and iterables are kind of like they're buddies. They go together. I'm iterable, so I give you an iterator. Comparables and comparators have a different relationship entirely. One's about a natural order. One's about another object entirely. That's a very interesting point. So it is not, like if I did an analogy, comparable is to comparator is not the same as iterable is to iterator. Cool question. Yeah. There's no default iterator. Is there some way that I could give an iterator over just the array? I don't think so because it's the whole array. Back to that question someone had earlier. But it's an interesting question. Is there some way to just iterate over just the array? But I think the answer is no. Okay. So what we did in order to make this work is we said array sets implement iterable. So array sets are iterable. And what does it mean to be iterable? You have an iterator method. What does the iterator return? An iterator. Okay. All right. So that's the story. All right. Now, this is how set works, by the way, or list, or map. So sets are collections, and then collections are iterables. There's actually a hierarchy of different interfaces. And in this particular case, you'll notice I'm using a keyword we have not taught in this class, but we will later, called extends. Okay? So the bottom line here, this is the one slide summary, is that if you want to be able to iterate using that colon, the for each operator, or the for each loop, you'll add an iterator method to your class that needs to return an iterator, and that's going to be a subclass that you build, or a nested class. That's not a subclass, sorry, a nested class. The iterator return should have a hasNext and next method, and then you need to say implements iterable when you define your class. Okay? All right. Great. Okay, I got a little grab bag for you of other things. So this is the hardest part to understand today. Next are just a couple of little episodic, useful pieces of knowledge. All right, any last questions about this? Yeah. We won't talk about ordered versus unordered sets. So here you might argue, like, why are you iterating in the particular order? Yeah. But no. Another way we could have written it, like, an exercise, if you're interested, you could change it so the array set iterator goes in sorted order, right? And that could be fun, maybe. All right. The last thing I want to talk about with Java before a little bit of useful stuff later, like extends, is understanding these object methods. So every class in Java is a hyponym of object. So I can always say object O equals anything that is a reference type. So today I'll be talking about toString and equals. At a future lecture, we'll talk about hash code. And then there's a bunch of methods we'll never use in this class, and some of which nobody uses. Okay. So the toString method is kind of like underscore underscore stir or underscore underscore repr in Python. It gives you a string representation of an object. If I, in Java, right now, take a Java set and I add 5, 23, and 42 and I print it out, I will get 5, 23, 42 in brackets. Now, whenever you call system.out.println with an object, it will always call this toString method. Like, that's just in the code for print line. So you can click there and see. It tries to call the toString method of whatever you're trying to print. Okay? By contrast, our array set now, if I were to go into IntelliJ and try to print out my set, I'll get something that looks like this. Array set at 75412C2F. And this right here is the memory location in the Java virtual machine that says where the array set is. That's the default way to print out an object. In 61C, you'll talk about what this memory location really means. But for us, just imagine it's where the array set is. So this is that address. Some programming languages, by the way, like C++, let you actually manipulate these addresses directly. So you can take an address of an object, like add 16, and then see what's there. That's not possible in Java. Java does not allow you to mess with memory addresses like that, which is one of the reasons that I think it's a good language for teaching second semester programming. But it's why Java is sometimes somewhat, well, it can't, C++ could be faster because you can take advantage of these fancy pointer tricks. All right? But we don't want these pointers. We want to see a meaningful toString implementation. So I'm going to go into array set, and I'm going to write myself a toString method. So I'll say public string toString. And now I'm going to return a string representation. I'm going to put override. I don't have to do that. But I'm doing that to remind myself that I'm overriding. And then I'm going to say string to return or whatever. I don't know what I called it. I'm going to start with an open curly brace because that's what I like. And then I'm going to say for t in this. Seems pretty reasonable. I'm going to go through myself. T in, why isn't that not working? Public string to string. What's it yelling at me about? Not a statement. Oh, for tx in this. So I'm taking each item in myself. And because, how does it know how to do this? All that stuff we just did. And then we're going to add to the string to return. So I'll say string to return plus equals x. String to return plus equals, let's say, comma space. And then at the end, we'll say string to return plus equals close braces. Nope. Uh-oh. Okay. Then we'll return the string to return. Okay. Let's see what it looks like. I think it should be fine. All right. If toString is kind of boring, equals is more interesting. If you're someone who's like, uh-oh. This seems sort of tedious. All right. We got closer. Oh, we printed out an array set iterator. How did I do that? That's interesting. Well, I don't have to call toString. Oh, I printed out the seer. Oh, ha, good point. Okay. All right. And we don't have a toString method for the seer. All right, thank you. Good catch. That would have been really annoying to try and diagnose. So notice we get 5, 23, 42. Okay? If you don't like that comma, you can make the code nicer. Is there a join method like in Python? There wasn't last time I thought about it. Yeah.
By default, does the toString method just print out the address of your address?
Yeah, by default, it gives you the address. Class name at address. Okay. All right. So this is what I just did. Now, actually, in IntelliJ, it'll yell at me. If you look, there's a warning here. And it says string concatenation plus equals in loop. I'm going to push option, enter. And then I'm going to push a button. And it changed my code. Instead of adding to the string, it made a string builder object and then did something else. I don't really want to get bogged down in this. I'll revisit this a little later, but it turns out this version of the code is more efficient. You can write it as the normal, like the thing that makes total intuitive sense to you, and then have IntelliJ fix it for you. I don't mind. But the basic idea is that adding a single character to a string means adding and making a whole new string. So if you have a 1,000,000 character long string and you add an exclamation point, you have to make an entirely new string, and that's because strings are immutable. We'll revisit this in one of the software engineering lectures later. Okay? All right. Any questions about this? That's the string. Yeah.
Will we be using these type of string, or will we be using string builders instead? Which, from what I've heard, are faster.
String builders are faster, indeed. So you can do it either way you want on assignments. I recommend doing it this way. IntelliJ will fix it for you, even if you don't know how string builders work.
Also, for the iterator, wait, so is it related to iterators?
I'm gonna take the iterator question after, just because I don't want to disrupt the flow. But feel free to catch me after. Okay, I got one more for you, which is equals. All right. So we built the toString method. Wasn't that exciting? Equals will be a little more interesting. Okay. So as I mentioned earlier in another lecture, equals and dot equals behave differently. Equals compares the bits. And the ideas that were for references, we're basically saying, do these two boxes have exactly the same 64 bits? So if I make two sets in Java, or two lists in Java or whatever, that both contain 5, 23, and 42, and I use equals, it's going to compare these two exact addresses, and it'll say, no, they're not the same. Instead, we should use dot equals. But in order for dot equals to work, we have to actually override dot equals. Okay? So equals in general, like by default, it just uses equals. That's the default behavior. Is if you say, is an array set dot equals another array set, it'll just check the addresses. But we want it to be some notion of semantic equality. Okay. Before I do this, I just want to also revisit the this keyword, which is to say that this is a reference to the current object. So it's the 64 bits of me. And naturally, you can use this to access your own instance variables and methods. This came up at some point, and it just never comes up earlier in the class. But unlike Python, where self is mandatory, like if you want to talk about yourself, you have to be using self. In Java, you don't have to say this if you don't want to. So these two pieces of code have exactly the same behavior. The only difference is in this particular left code, I say, is my size bigger than the other size? If you don't say this, it implicitly puts this. Okay. Just be aware. All right. Another little thing that comes up occasionally is that if there's ever a name conflict where the constructor, for example, or the function you're working with has a parameter that's the same name as a local variable, then you have to use this dot size if you want it to work correctly. Okay, so if there's a conflict, you should be using this. A better approach, in my opinion, is not to have the exact same variable name, but you can use this. Okay. Anyway, digression. Let's talk more about equals, though. So the actual code for the equals method in object.java, you can click here and look at the code for object.java, because remember that most of Java is written in Java. This is the equals method. And what does it do by default? It just checks the addresses. Okay. Do we want that? No, we want something better. We want it to be checking the contents of the two array sets. Okay. Someone else has something at 2, I see. All right. So what I'm going to do is I'm going to use, okay, so I want to write my own equals method. Actually, I'm going to go into IntelliJ and start writing it, so to get ourselves primed. So I'm going to say public, what type do you think equals returns? Boolean, right? Equals, what kind of argument do you think it takes? Someone said object. I'm going to put array set first. It's wrong. So if you put array set, this is not good because this will never get called. If you put override, it'll yell at you and say, you are a dummy. You're not supposed to say array set. You should be saying object. Another reason that override's good, it just catches that error. And now I need to start trying to compare the other object. Okay, great. So let's check. So what do I need to know? Well, I'm going to check, like, if this dot size is not equal to the other array size, then they can't be equal. I could return false. Right? I should say, I'm going to use the function size. Okay, so someone gives me something and I check its size. Oh, but we've run into trouble. There's no size in object. Like, what if someone's comparing me to a dog or a cat or a list or something? So I need this object to not be type object. In fact, what I really need to do, what do I need to check first? Check if O is an array set. Okay, so how do I do that? To do that, we'll use instance of. Okay? All right, so let's go back over to the slides real quick. This is a very simple example of an equals method in a dog class. And I'm showing you this because instance of is a pretty subtle keyword in Java. It actually does a lot. So if I say if O instance of dog a dog, this does the following. First it checks, is O a dog? Okay. If O is a dog, it creates a new variable called a dog that's of what type? Dog. So it like takes that object and says, you are really a dog. Live in a doghouse. Okay? And now that it's a dog variable, what can we do with it? We can access its size variable, right? If the answer is no, then it won't do this. It'll just fall through the loop. And it's also nice because it's null safe. So even if O is a null, you don't have to have some special case. So if you look at equals methods that were written before 2021, there was like, if O is null, do this thing. Is O actually the same class? If so, do this thing. If not, do this other thing. But instance of was brought into Java. This new feature in 2021, this is something called pattern matching, which is a really nice feature in programming languages. It's a little funky because it's like a check and a transformation, but it's very nice. Question? Why are we not saying O.size here? No. Yeah. Yeah. Oh, why isn't this just dog? That has to do with the way that Java decides which functions to call whenever you call a sub. It has to do with the way subtype polymorphism works in Java. Right. So it won't work for overriding with these other signatures. And if you really want to go deep into this, please look into the horrible abyss that was 62NB, lecture 11, 2 or 3 years ago, where we got into this in more detail. Yeah.
Would it let you implement like an overload to specify which type of object?
So could you overload it as equals dog? Yeah, it just wouldn't get called when you expect it to get called. That's the trouble. Yeah. We're overriding this actually not from any, we're overriding it from object. So object is sort of the big granddaddy class of all classes. Right, if you called equals dog, it won't get called when you expect it to get called. Not always. Yeah. Where am I implementing it? Oh, yeah. So the question was, I didn't say implements object at the top, right? But it's always there, because everything's an object. Okay? So let's try using O instance of here. So I'm going to check if O is an array set. So I'll say if O instance of array set, and then I need to call it something. Set, I think someone said. All right. So if O is an instance of array set, now I have a variable called. So if O is actually an array set, now I have set, which is of type array set. Right, okay. So we can do something like if this dot size is not equal to set dot size. They're not the same size, I return false. What else do I need to check for two sets to be equal? Are the elements the same? Okay, so I'll iterate over all the elements. So how do I do that? For x colon this. Okay, I'll look through all of myself, and then I'll say set dot what? Contains x. Okay, so I'll do set dot contains x. Then if it doesn't contain, what should we do? Return false. The last thing we'll do is if we have the same size and the same items, then return true. Okay, and then lastly, if neither of those things, if something went wrong, like if it wasn't an array set, so let me make this smaller. If it wasn't an array set, or it had the wrong size, well, these are actually already false. So if it wasn't an array set, what should we do? False. Okay, and that's our equals method. Okay, so that's a little interesting, I think, this instance of thing. Any questions about this? Yeah. So the question was, could we just convert them both into a string and check them? That might work sometimes. And in fact, that might work here. Like I could do something like return, let's see, set to string dot equals this dot to string. That'd probably also work. Yeah, it just might be slower. But fair point. It actually might be faster, honestly, because of the way we wrote contains. because contains is going to keep going through the array. So I think your approach would actually be faster. Yeah.
If we know that X is an array set, why are we using a generic there in the for loop?
If we know that X is an array set, here? Oh, these are each item in the array set. Yeah. Yeah. This doesn't check for order, but I'm assuming these are unordered sets. Yeah. So I can't do o.size because that's not an array set. When I do this line of code, set is pointing at the thing you passed me. Does that make sense? So it's not making a copy. It's just like this has two effects. It checks if O is an array set, and if so, then it makes a new variable. You can imagine there's an extra secret line here that says array set, set equals an array set version of O. Does that make sense? It only works if O is an array set, and if it's not, we're assuming equals should be false. If O is an array set, why? Because Java, the compiler, if I do O size, the compiler is very picky, and it says, I only know its object. So that happens before the code runs. Yeah. All right. Okay. Any other questions? Yeah. Sorry, say again? I think it's the same as is in Python, but I'm not that good at Python. There's one more thing in Java that you can do to make your code slightly faster, which is before you start, say if this equals other, return true. Because it's like if it's actually two references to the same object, you don't have to do all this work. Small optimization. So summarizing everything we have here, we built an array-based set, and there's several things we made better. We had an exception if someone tried to add null. I didn't actually do that live, but if you want, you can see the videos or some thinking about that, the pre-recorded ones. We added ugly, then nice iteration, a toString method, then equals. And if you're interested, I have a couple of extra bonus things, which is an even better toString. Like, oh, it does have join, I forgot. And then the other one is how you can write an of method that you might have seen before, which is kind of fun. So if you want to be able to do like list.of, this is how you do it. But that's a bonus video. All right, we're done with Java for now. I'll see you guys on Friday. Yeah.
For project 1B, when we're implementing the iterator, should we also have like an iterator method in the DQ60B interface? Or do we just have to say that DQ61B implements iterator?
Right. Once you say DQ61B implements iterator, then that gets inherited by all of its subclasses, so you don't have to explicitly say it.